So, like I said, I am just testing out some of my Open Broadcast software and kind of a new setup that I have here, which is similar to what I used when I used to be at the Makerspace. And what I'm going to do here is first grab a drink of water. So, what I've got is a bunch of components that are all set up in a bunch of wires like this. Not great, but I do need to use them, so I am going to do a little bit of cleanup. I do have a bunch of stuff like this, which is components that I did already set up for use because I'm building a lot of smart speakers right now. So let's sort this out. Got a couple of buttons. I have got these guys, which I'm pretty sure I did do cleanup on yesterday. So just removed a bunch of the components from this one and then cleared out all of the through holes. So those are basically ready to set up again. And I've got a couple of other things like that. A couple of things like speakers, so those are good to go. This one is a fun one. This one is a this one's an audio transducer, and basically what an audio transducer does is instead of moving air for creating sound, it moves a physical object. So you can attach this to a physical object and then it will actually vibrate it in such a way where it's going to make some sound. So I am going to go ahead and remove the wires for that. This was used in a proof of concept, which, I mean, it worked well, except this was the wrong audio transducer to use for that project. It was just a little too big. Let's see. Alright, so here I have an old setup from my speaker system. This one does have like an old inexpensive speaker that I was trying to use. I am not going to use that speaker because I have some much better ones. So I am going to remove the speaker part from that, and I'll save it for another speaker. But yeah, so this is the old system that I've been using. In order to clean up some of the wires, I am using a newer setup. So I'm just going to cut. I think I need that right now. I'm just going to cut that heat shrink off. get to the circuit board. And since I've pretty much run out of these audio DAC amplifiers, I do want to reuse this. Grab this back here and do a safe thing and put that away. And then I'm going to pull out these wires. So just feed them up and come right out. This one's tricky because it's a 3 connector wire, but not too bad. Alright. This microphone is kind of in the same position. I do have a lot of these though, so I'm wondering, yeah, you know what, I'm trying to go with the standard here, so I am gonna stick with the standard and make sure all of these components are set up the same way. There we go. Don't need that. Let's go ahead and do power and ground. There we go. Super liking the color on this camera, so I apologize. I'm gonna try and see if I can adjust the color. Let's see, soldering can. Saturation is good. Yeah, see how that's kind of like orangey yellow? I don't want that. Let's see. Let's try and adjust the white balance. Oh, look at that. So much better. It has been a really long time since I've used this software. So yeah, I'm not super used to it. But that looks a lot better. Please excuse my fingernails. My nail polish has been coming off as I have been working in the workshop here. Trying to get things cleaned up now that I am working on a bunch of projects. So just using the solder sucker here, which does a beautiful job of cleaning out those through hole sockets that I just pulled a bunch of wires out of. And that's going to make it a lot easier to do the rest of the stuff. Beautiful. So let's see if you can see it here, but those holes are completely solder free. And that is a component that I can put back in circulation. One of the things that does make it difficult to do hardware stuff is that you actually have to buy the hardware. And it can be a really, like, it adds up with all the components that you get. They're not too expensive, but when you gotta buy like 30 or 40 of them, adds up. And especially with stuff like this. Oh, that one didn't quite clear. It helps to be able to reuse some of them. Ooh. Stuck. Alright, that one is getting a little stuck, so let me add a bit more solder there so I can make sure to get it good and heated up. Oh, I think my solder sucker has gotten stuck. Another tool. Okay. Alright. The other tool that I had was for 3D printing stuff. So I'm gonna see if a little bit of this, and that was a little too small. I was hoping that piece of filament would help, but it is not. So what else have I got in here? I used to have another thing like this that let me poke stuff out. Let's see if this will do it. Oh, yes. Got that solder plug out. I think I should keep this handy. Because that does happen. Alright, now let's try that again. There we go. Alright. That is great. Clear out these connectors too, because I am using a different gauge wire now. There we go. Clear out these holes. Amplifier. Let's see. We've got two other amplifiers. These are. Oh, let's see. Actually, is that an amplifier? Yeah. No, that is an amplifier. Yeah. So this is the official Adafruit one that I got a while ago, and I think this was the original one that I had started using. Yeah, you can see this is when I was first testing it, and it's got a bunch of different colored wires, which is really helpful for when you're starting out with stuff. The other one that I have, this was one when I set one up for doing breadboarding, but I have a different one now that I use for breadboarding, so that one can go back into circulation. Wires out. There's nothing wrong with these wires, but as I have been evolving with this design, there are a lot of wires in here, and they get really tangled up. And now that I have a lot of the difficult questions answered, like what components need to be wired to where, the color of the wires is not really important anymore, and so I've switched to some ribbon cables that just keep everything together and reduce the amount of total individual wires, so things go a lot cleaner. Alright. Yep, all those are cleaned up. Let me just get the two over here. Go. That is all cleaned up. Get this one. I do actually want to save these jumper wires though. These are jumpers with a bunch of header pins that I made. Let me get this. Try and get this to a better position. So this has a bunch of jumper wires, which let's readjust this a little bit. That is going to make it a little tougher for me to get into my drawers, but hopefully that is a little bit easier to see. So yeah, I got these jumper wires here, and these are actually made out of silicon wire, and then I added the jumpers, so it's really great for this kind of prototyping thing. And I actually have this new, let's see, which one is this one? I think this is, yes, so this is an accelerometer, but I'm not actually going to use this accelerometer. I have these accelerometers, and these are what I'm going to use. Oh shoot, is that actually the same one? That might be the same one. Yeah, that's totally the same one. So these are the accelerometers I'm going to be using, because apparently they will work with ESP Home. If I remember correctly, that is a 3-axis accelerometer and 3-axis magnetometer, but specifically set up for doing orientation tracking, which I kind of thought would do really great for the NaviPal. I think being able to kind of detect what orientation this is, do an acknowledgement by shaking it, turning it upside down or laying it backwards to put it to sleep or something. I'm real interested in the types of things that we can do if I can get the accelerometer going. So I'm going to need some of these. Checking on a few things. Okay. So let me go ahead and remove these jumper wires, and I am going to eventually repurpose them for that accelerometer, because the accelerometer uses I2C, and that only needs 4 connectors. So usually it's data, clock, and power and ground, which should do just fine for these colors. And then I can have one of those set up to do breadboarding, which is how I usually test out to see if I'm using the right pins. I do love the ESP32 because so much of the stuff can be configured through the firmware that you write. But what I've also found is that certain pins, while you can assign them to be used for things like I2C and I2S, if you do that, it does interfere with other things. Like, perfect example is I did a bit of wire cleanup to my schematic to make the ribbon cable just fit a lot easier without having to spread out the connections and just have them in a row, and it worked really well, but it basically, the 2 of the pins that I used interfered with the startup for Wi-Fi, and I was no longer able to send over-the-air firmware updates, which made it very difficult and frustrating. And so I just had to switch those to another couple of pins and basically mark those 2 pins that I used before as off limits, because over-the-air Wi-Fi updates are actually pretty useful. Alright, look at that. I keep that tool handy. And that makes it much easier to clean this up. I cross-thread that. Didn't go through. Much better. There we go. Those are all clean. Switch it around. Those last two through holes. This is where you actually connect the speaker up with this amplifier. Ooh, yow! Okay. Pinched by that spring coming back. Alright. So that's another audio amplifier. Now what I'm going to do is go and tackle some of these guys. So what these are the M5 Atom Echo devices. These basically are what these are basically like a smart speaker on a board. They have the microphone, an LED, push button, and built-in amplifier on them. So this attaches to a little speaker. They're not super powerful. The amplifier isn't really powerful, but these are actually really handy for smaller application stuff. I do want to have a couple of these because they are going to come in real handy for a project that I have. Essentially, there's a fun thing that I want to do. So this purse is one of the things that I am going to be trying to put a smart device into, and I thought this is perfect because the handset here, it actually has a speaker and a microphone in it, and even has a button pushback. And what I can do is I can put this Atom 5 Echo into the into this handset, and then basically I can talk to the AI like this rather than having it announce everything outside. I personally think that would be a really great thing, especially for an AI conversation model that you're talking to like out in the world, so that way you don't have to kind of disrupt everyone else's day by talking to something else. Alright, let's see. So just to make this easier for me, actually no, I'm going to stick to just doing cleanup stuff today. So I'm going to put that in the microcontroller pile. to take this other one. Let's see. So this one, I believe, is connected to power and ground. Wow, that is a really messy soldering job past me. Yeah, I'm gonna leave that as is. Let's see, it does have all the other stuff on it. So yeah, that one should be good. Let's see, what do we have next? We have a couple of microphones. So these are the new setups that I have for the microphones. You can see they are very much more simple. Just one, let's see, it's 5 wires in a strip that are connecting that. So those are actually exactly how I want them to be. I am going to put those over here in the components that I am going to be using later. Let's see, another button component. This is the power supply basically that I've been using, which is the Adafruit Boost 100. Let's see, this has everything I need on it. Yeah, actually that's pretty much all set. Oh wait, actually. Oh yeah, no, okay. That is the power shut off. Let's see. This one, I'm pretty sure is one of the new ones. And I just haven't added all of the stuff onto it. I think what happened with this is I ran out of these magnetic power connectors. I have a different one here somewhere that I want to do with this, a barrel connector, but I also just ordered those, so hopefully I will get those soon. Let's see, a little thing of LEDs. I'm just going to throw that in my LED drawer. And yeah, no, I don't need that. And ew, these are vinyl wires. A lot of the batteries that I get and older components come with vinyl wires. I am in the process of phasing all vinyl wires out of my stock because they're just they're real stiff and they just don't bend really well. And I do a lot of like wearable stuff, but I also do a lot of things where I'm having to cram it in a enclosure like this. And I'm not gonna lie, it makes it so much easier to not have to deal with this stuff. The silicon wire, it is expensive, but it's so worth using. Highly recommend it. So I think that might be, well, let's see now, I got a couple of components here. Let's see, oh yes, I can clean up that because right now one of the things I'm running really low on is the power supplies. Most of the other stuff I do have quite a bit of, but the power supplies right now are in a bit of high demand in my workshop. So This one is a much older. It is still a Power Boost 1000. Yes. I have a bunch of Power Boost 500s as well. The difference is this does 1,000 milliamps. The other does 500 milliamps. This is a much older version where I was playing around with doing induction charging, which, I mean, it does work. It caused a lot more problems with doing this guy than anything else. And so I've switched to the magnets just because with induction charging you have to make sure that things get lined up properly, and if things aren't lined up properly, then you get a drastic reduction in the charge, which is not great all the time. There's some purposes where it works really well. This was not one of those purposes. Oh boy, I used the double-sided foam tape for this. Let's see if I can get that off enough to access these pins. Because with my new enclosure, I do specifically want this board to be face down so that I get things that line up with the indicator lights. You can kind of see that. You can see that here where I've got this indicator light is for showing that it's powered on. This says that it's charging, so you can see if I unplug it, it's not charging, but the power light is on, and if I put that back, then it starts charging again. So that's just a handy thing with, I do love how Limor set up this board. It is so good, and being able to actually detect the battery charge with an analog pin is so useful. I essentially in these smart assistant devices, I have it set up so that when the battery starts getting low, it doesn't start flashing a light or anything. It actually just uses the text-to-speech to say, hey, your battery's getting low, you should plug me in. Alright, so that is the 5-volt and ground. Let me put this in the thing here. Hold that in place. There's wires out. I do have a couple of these induction chargers that I got real cheap, and eventually I will use them for something else. Ooh, you know what? I kind of regret getting the battery connector off of this. It's just a pretty standard JST connector, but I have a bunch of these surface mount replacements, and what I'm going to do is I'm just going to put another one on, because thankfully I removed this originally in a way that did not rip off the pads. So if I'm careful, I am pretty sure I can just nip this right off. Yes. Alright, let me clean that up. Let me actually move that a little bit closer here so you all can see what I'm doing. Of course, unfortunately, I can't see what I'm doing if I tilt it in the right direction. But yeah, so you can see I removed it. I'm just gonna try and polish off those pads. So this is a JST connector. Which one is this? It's the JST PH2 male connectors. It's basically these guys here, and I get them off of DigiKey. I have a whole bunch exactly for this reason. They can be a little tricky to install, but I'll let you get a look at how clean that is now. And then so basically what I have to do is kind of hold it in place there. Get this side tacked down. I think I'm gonna go with the tweezers again. Just so I can get my fingers out of the way. Alright, so what I'm gonna do is put a bit of a blob of solder on here. These little side connectors actually aren't connected to anything. They're just for stability, because this is a JST connector. It's meant to have things plugged and unplugged all the time, so there's a bit of stress that is applied to this connection. And what these two little things on the side do is they just basically take the pressure off of that, so you don't end up damaging the board or the connections. So just flow a bit of solder in there, and now, so that is stabilized, and I'm just going to now connect the cathode and anode pin. There's a small space to get into. Whoop, nope. I just jumped over to a capacitor that's right near there. Do not want to do that. Let's try and reflow that. Alright, I think it's just too much solder. So I'm going to see if I can remove some of that with the solder sucker. Yep. Looks like it did it. Just reflow some of that solder. Do the other connection because it's looking kind of dull. When your solder joints look a little dull, it can be an indication of a cold solder joint, which is just not going to be as effective with conducting a signal. But I'm also using non-lead based solder, and sometimes that can just naturally cool with a bit of a dull sheen to it. Just want to inspect and make sure I don't have a bridge there. Nope. That looks good. Yeah. I think that's good. Battery connector back on there. And I can compare it to this. It's not exactly the same battery connector, but it is made for the same battery, so that should work just fine. Let's see. I am going to go ahead and clean out these through holes here. Whoop. Appears to have a bit of wire stuck down in it, so I'm gonna just loop a bit of solder in there, and that should hopefully heat everything up right down to that wire. And just pull the whole wire in there. Like it did not do that. Let's try that again. There we go. Huh. Still a little something in there, but I don't think it's enough for me to have to do too much. I can make that work. That one is not flowed all the way through, so let's add a bit more solder on the other side. This may not be fully salvageable. I mean, not salvageable in like the ideal case, so this one might be one that I might use for my own projects. Definitely not one that I'd want to send out to someone else, but I can still use that. Let's see. Continuing on with cleanup stuff. So one of the things that that I commonly have to do is fix these lithium batteries. I've got a bunch here, and pretty much like what I was saying with the silicon wire, these come with vinyl wire. I think this one was already replaced with a bit of better silicon wire, but still not as good as the stuff that I get now. But most of these come with this just horrible vinyl wire. Now it feels bad, like it just feels rubbery, like hard rubber. If you've ever soldered vinyl wire, you know exactly what I'm talking about. But also, if you bend this a whole bunch of times, it will eventually break. It does, the stiffness of the wire also makes it so points like this this joint here, where you have a hard device with the wire interface. If you bend that back and forth enough times, this is going to break. So that is a breaking point. So what I usually do is I will replace these vinyl wires with silicon wires. These are actually doing all right, and I have projects that I'm okay using that in. I also want to make sure that the polarity on these connectors are consistent with what I'm using. But there's ones like this, which this just looks really bad. It is on the verge of breaking. And that one's not too bad. That one's okay. This one, so this is what I've been kind of moving towards. I have these little USB-C lithium battery chargers, and connecting the battery to that. I do need to put a connector on here, a JST connector, so that will connect with everything else. So I think I am going to do that. I need to replace this. I need to replace this as well, so I'm just going to go ahead and do that. And in order to do that, I have to grab my little drawer of silicon JST connectors. So this is the female of the JST PH 2 pins, and I don't really need I don't need the helping hand for this one, I don't think. So what I'm going to do is pull this out. Okay, maybe I do need that little clamp, just because I need to actually pull this. Alright, so the battery is going to stay. I'm going to pull this apart so I can do these one at a time. Much easier. Alright. now I am going to put these connectors in. So I'm doing positive in there. Actually gonna cut these pre-tinned tips off and get a better one. Oh, I got someone in the chat. Zoomed in camera is like I said, this is a new system that I'm checking out, so I'm trying to get used to like checking out chat and stuff too while I'm going. Figure there's not too much that I'm doing here, so this would be a good test run. Alright, so let's see if I can slip this wire in. Yeah, this wire is pretty thick for the through hole that I'm putting it in. And this is stranded wire. So I want to make sure that it stays nice and put together. Or it's just not going to fit. So I'm just going to solder the wire to the top of the pad, and I'm going to seal this one with some heat shrink tubing or Kapton tape just to make sure nothing accidentally touches it. solder on there. That one is soldered up. There we go. Alright, so there is the battery with charger and a JST connector so that you can then use the power of that battery. This is one that I'm probably going to use in personal projects, so I'm just going to do a bit of Kapton tape, which I have somewhere around here. Yeah, I can do that later. Alright, now I am going to do these batteries. This is something that if you do, you have to be kind of cautious about, because lithium batteries do not like heat. They have a special connector here. Most of these lithium batteries don't solder to a lithium battery. That is bad, and you're going to end up with swelling because they don't like heat that much. So what you want to do, you'll notice that like it's got this little board here, and what this board is this is a piece that is soldered on. I'll get a little closer there. This is basically protection circuitry. So this keeps it more difficult for you to harm this battery. It is connected. This one's not done very well with just regular tape. I do have Kapton tape, so I'm gonna fix that as well. In fact, this battery is probably already damaged, so I don't really want to use it for anything other than my own stuff. And even at that, like, I don't want to leave this alone. Especially while charging. So, what I'm going to do is I'm going to solder onto this connection, this extra board here. And I'm not going to, well, I'm going to try not to linger too much on there, because I don't want to cause any heat damage to the battery. Get those two off. Alright. And then I am going to do power and ground. Solder flowing. Let me actually just get a big blob of solder so that should flow a lot nicer. Get that wire in there. There we go. Alright, there we go. So now I got the new wire connection on there. I'm going to grab some of my Kapton tape. I have, ooh yes, there we go. Much bigger roll of Kapton tape. Kapton tape is something that you would find in a lot of electronics. It's basically non-conductive, but more importantly, it is heat resistant. So it is great for use on stuff like this, where we have a battery that could potentially get overheated, and this is not only going to protect anything that might accidentally touch the battery, but it is also going to help if things overheat. It will not melt, or I should say, if it does melt, then there is a much larger problem, because that is a lot of heat. Let's see. Do you want to go? You want to go a little bit higher on this. Just so I get that sealed. This is not the best job of putting on the Kapton tape, but as you can probably see on the camera, this battery is a little rough anyways, and I am probably not going to use this in many projects other than my own kind of hacky projects. But there is another battery. Let's go ahead and get this one. This one is a really old project, because I have not used this electrical tape in a long time. So that's how I can kind of date my projects, is what kind of electrical tape did I use. Getting Kapton tape off of this. I think this is actually one of the ones I got from Adafruit, so it's got a pretty good job. Of having that in there. I think I can reuse some of that Kapton tape, because it is fold it over real nice. Let's get rid of those. You want to hold that flap back. So let me just do that. I'm going to put a little bit of extra solder on there. Being very careful not to connect the positive to the negative. This battery's been kind of sitting for a while, so I'm pretty sure it is discharged, but I do not want to make that mistake. Go. That one was a lot easier than the other one. Going to put this Kapton tape flap back over. Then I can take a bigger roll. Stick it a little bit higher on itself so that something doesn't accidentally get things connected. So I think that's good enough for now. So that's a couple of batteries that I've reclaimed that have not seen the best of days, and I think that is going to be it for testing out this new setup. And I am going to go do a few other things, and then I think I'm going to try doing a deconstruction video here in a bit. There's a device that I've been meaning to pull apart, and I might as well use this new setup to try that out. Alright, that is it. Turn off soldering iron.
Turned off the switch.
Perfect. Alright, see you guys.